Hello students, let's try to understand 50 problems on the hydroboration oxidation. So student, diborane is B2S6 student. So if you are taking BH3 two molecule it found in the dimer, so it will give B2S6, that is called diborane, right student. React with alkenes to give the trialkyl borane. The initial step what it is going, trialkyl borane as addition product. So let us try to understand student. This is the alkene, right, CH2, and you are going to add with the HBH2, right. So borane I am taking BH3, right. So how I am writing student? So what you need to do, you will add the one hydrogen here and BH2 here. So you are going to get the intermediate student CH3, CH2 and BH2. Now this boron is having two hydrogen. So firstly you add one more alkene group student, alkene here. So what will happen? This hydrogen is going to add here student. So what it is going to give student, CH3, CH2, it is going to give whole twice BH. But what is there, one more hydrogen is there with the boron, so it is going to be add with the another molecule of the alkene. This hydrogen is going to add here. So let us see student, what is the intermediate you are going to get here, CH3, CH2, it will be 3 times boron. This is called student trialkyl boron. This is called trialkyl boron. Okay, borane, not boron, trialkyl borane. Now student, what they are saying, this is the diborane react with alkenes to give trialkyl boranes as addition product. This is oxidized to alcohol by hydrogen peroxide in presence of base. The reaction takes place according to anti-Markovnikov's rule. Now student, whatever the reaction is there, this one you see in the basic medium student, what you are writing, OH and OH, this is the 3 molecule you have to take peroxide student, this is hydrogen peroxide. So it is what is forming BOH 3 times student, this is forming BOH 3 times, and 3 mole of what student, ethanol is going to get. This is the OH, this OH is going to be add here student. So 3 molecule of ethanol. So this is the one reaction. Now go with the second one student. Suppose you are taking unsymmetrical alkene student, CH3, this is what, CH double bond CH2, and you are treating with the HBH2 student. So you got to know this is going to be here and this is going to be here student. What you are going to get here, CH3, this is the CH2, again CH2, and here is BH2. Since 2 hydrogen is there with the boron here student, so you can add one more molecule of propene, CH3, CH double bond CH2. So student, this hydrogen is going to be add here. So let us try to understand student. CH3, this is what going to be CH2, this is again CH2, this will be the 2 times student, that is going to be BH, right student. Now again you add, that is another molecule of propane, CH3, CH double bond CH2. So here you are going to add here, right student. So dear student, let us see what is going to form, CH3, CH2, CH2, how many molecules student, this is 3 times B. This is trialkyl borane, this is called student trialkyl borane. Now this trialkyl borane, what is going to happen student, you are oxidizing this trialkyl borane with the help of hydrogen peroxide in the basic medium. Hydrogen peroxide we write according to structure, 3 molecule you take hydrogen peroxide student. So it is boron trihydroxide is going to be out student, BOH whole thrice is out, and what is left behind student, 3 molecule of propanol, CH3, CH2, CH2, and this OH is going to be here. So CH2 and this will be OH. So this is what student, 3 molecule of propanol we got student. I know propane 1 all, propane 1 all. How many molecule student? 3 molecule. Suppose you are taking some other molecule, suppose you are taking third example. So third example you can take, that is but1ene student, CH2, here is CH, right, here is CH, this is the double bond CH2. Now diborane we are taking, to borane, so this hydrogen is going to be here, boron is going to be here. So let us see the intermediate. So CH3, this is CH2, then CH2, then here is CH2. This is what is going to happen here at the end, student. This is the BH2. This is, now student you can see there is how many, 2 hydrogen are there. So you add another molecule of propene here. So here is CH3, CH2, this is CH, double bond CH2. So this hydrogen is coming here, student. Let us see what the intermediate you are going, you are dialkyl borane you are going to get. CH3, this is CH2, one alkene, and this one CH2, again CH2, again CH2, 2 times, student, this is the BH. Now what is the condition here? There is, since one more hydrogen is there, that can reduce the another molecule of butene. So CH3, CH2, here is CH double bond CH2 is there, so it is going to be add here. Now see, trialkyl borane you are going to get, student, CH3, this is the dialkyl borane, dialkyl borane, and this is what we are going to receive, student, trialkyl borane, CH3, CH2, CH2. How many times, student? This will be the 3 times B. This is called, student, trialkyl borane. Friend, now this trialkyl borane is going to oxidize in the basic medium by the hydrogen peroxide. How many hydrogen peroxide you need to take? 3. Now student, this B and OH will be out, student. So this is what BOH whole thrice, student. And what is the left one, student? Here is 3 molecule of CH3, this is the CH2, this is the CH2, again CH2, and friend OH. So this is what is, student, butane 1 all, student. The product is butane 1 all. Now let us move on the fourth one, example number 4, student. So when you are taking fourth one, now we are having the only option to take the unsymmetrical alkene, student. Suppose, friends, what alkene you are going to take here? This is the alkene, student, right, unsymmetrical alkene. Now with this unsymmetrical alkene you are going to add the BH2. So what you are going to get here, student, hydrogen will be added here and BH2 will be added here. So this is what the product you are going to get, student. Here is the BH2, right. Since here you will find that is 2 hydrogen are there, so 2 more alkene can be added here, right, this type. So 2 hydrogen will go here. So what will be left, student? Here you will find this is the compound, student. How many times it will be there, student? This will be the 3 times, and here will be B, student. Now student, you can do the oxidation in the basic medium with the help of what, student? Hydrogen peroxide. How many molecule you need to take, student? 3 molecule. So this is BOH whole thrice. You see, student, how it is going to be out, BOH 3 times. And what is the left one, student? This is the product. How many molecule? 3. This is the bond, student. Since it is syn addition, student, so OH group will be here. So what is the product, student? 1, 2, 3. So 2 methyl, student, 2 methyl, propane 1 all, 2 methyl propane 1 all, right. So every time you are saying that is OH group is going to add with the anti-Markovnikov's rule, student. Now let us move on the problem number 5th, student. What is the problem number 5th? Friend, if suppose the reaction is like that, okay, suppose this is the reaction this way, and you are treating with the what, student? The condition. Now I am writing the short note. student, not writing in the decel. So first condition you can take the BH3 student, and second condition what you need to take friend, second condition you are going to oxidize this one, right? So you are oxidizing with the what, H2O2 student in the basic medium. So OH group is going to add on the particular carbon which is having the more number of hydrogen with the double bond. So what will be the product here student? This is single bond, and student here will be the OH group will be going to add student. So this is what the product. Now let us move on the next one student. What is the next one? Suppose this one is there student, this is the 6th number we are going, 6. So here suppose this is there student, here is the methyl group is there, and this is double bond, and they are saying you use the term BH3 student, here is H2O2 and OH minus. So what you are going to get here student, what you are going to get here? So OH group is going to add on which position, that you need to find out. So OH group is going to be, this is the bond and here is the OH group, because here is, if you see, more number of hydrogen is here, and hydrogen will be as it is, one hydrogen from here it is go here, and OH will be going here, right? Now let us move on the problem number 7 student. Dear student, if suppose you are having the example, quite different example, the double bond you can see here, if the double bond is there on this position student. So what is there student? BH3 if you are adding, the first condition, and second condition is H2O2 in presence of what student? OH minus. So where the OH group is going to be added student? The according to anti-Markovnikov rule. So this will be the OH group is here student, right? This is the what is the product. Now let us move on the problem number 8 student. So problem number 8 if you are going student, dear student, so what is this? Let us see. This is the what the reactant we are taking student, and first condition is BH3 and second condition is H2O2 in basic medium. Here the hydrogen is more and here the hydrogen is less student. So this is hydrogen of this will go here and OH will attack here according to anti-Markovnikov's rule. So what is the product here you will find student? This is going here, it will form the OH, this position. So this is what is the product student. Now move on the problem number 9 student. Problem number 9. Suppose we are having the compound like this student. This is the double bond is here, and the same HBO reaction student, hydroboration oxidation. So here is BH3 student, and second condition is what? H2O2 in the basic medium student. So what the product you will find student? Here you can see, this is the, this position is there student. So OH will be downside. This is the OH group student. Let me rewrite here OH group. So here is the OH student, this is OH. So this is what we got the product student. Now let us move on the problem number 10 student. What is the 10 number? Here double bond is there student. This is now BH3 is there, the first condition. Sound, decrease sound. So dear student, here is BH3 and second condition is H2O2 friend, and here is the basic medium dear student. So what is going to happen dear student? This one. So where the OH group will be added according to anti-Markovnikov, this position less hydrogen. So more hydrogen, this position more hydrogen, this position less hydrogen. So here will be the OH group will be going to add out student. So this is what. Now let us try to understand student. One more example you can take student. Okay, problem number 11 we are talking student, 11 number. So if you are seeing this one, here is this one student, this is the double bond, friend. Now you are treating with the what, BH3 student, and second one H2O2 is there in the basic medium. So you see student, 1 2 3 4, so 0 hydrogen is there in this position. Hydrogen is the 0 number, right student? Here is this position, if you see 0 hydrogen. So and this position how much is student? 1 hydrogen. So according to anti-Markovnikov's rule, OH is going to be that position where hydrogen is more. So what is the product, friend? If you are writing the product, here you see the OH group will be adding to this position, and hydrogen will be here, 1 hydrogen is going to add it here. That you need not to mention. If you are not mentioning hydrogen, it is automatically understood that position is hydrogen. So in this video this much is okay student. In the next video we are going to make some more problems. Okay, so thank you so much for watching, friend. If you find this video helpful, please do like and subscribe the channel.